This video is looking at the roots of quadratic equations. Now recall from mathematical methods, quadratics, that the discriminant delta is b squared minus 4ac. Now that's coming from our quadratic formula where x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. So your discriminant or delta is there. Now, you'd recall that when delta was negative, we said we had no solutions. Our parabola is above or below the line, the x-axis I mean. If delta was 0, we had one solution or x-intercept because our parabola sat on the x-axis, and when delta was greater than 0 or positive, we ended up with two solutions. Now, with the introduction of complex numbers, it can now be stated that if delta is less than 0, then the equation has one pair of complex conjugate roots. Okay, so they're going to be in the form of a plus or minus bi, and that's why they're conjugate roots. You've got a plus bi and a minus bi. So let's start with some easy ones. Solve the following over C. Now it's over the complex number system, not the real, so we know that we can use I. Now I'm going to use two methods for doing these. Firstly, if I just take 16 to the other side, I get z squared is negative 16. So z has to be plus or minus the square root of negative 16, which is plus or minus the square root of 16 times by the square root of negative 1, which is plus or minus 4i. Alternatively, I can factorize. I can only factorize where I have a minus in the middle. So what I do is I change 16 to negative 16i squared. Now they're the same thing because it's negative 16 times negative 1, which is 16. So instead of putting 16, I'm going to put minus 16i squared equals 0. Now I can factorize it because I've got the difference of two squares. So if it helps you, I'll do the intermediate step here. So it's z squared minus 4i all squared equals 0. You don't need to do that step though. So you've got z plus 4i, z minus 4i equals 0. So using the null factor law, z has to equal plus or minus 4i. If you can't see that, remember where you go. Z plus 4i equals 0. So z has to be negative 4i. And z minus 4i has to equal 0. So z equals 4i. Pause the video and have a go at the next one, remembering you need to take out the factor of 2. Okay, so for the next one, if we bring out the factor of 2, we've got 2z squared plus 3 equals 0. We have the 0, so we can divide both sides by 0 and just have z squared plus 3 equals 0. Again, I'll use both methods. So z squared, take the 3 over, we get negative 3. So z has to equal plus or minus the square root of negative 3, which is plus or minus the square root of 3i. By factorizing, I need a minus in the middle, so I need it to be minus, and I put my 3, but I times it by I squared, remembering that minus 3i squared is exactly the same as positive 3. So that equals 0. Now I can factorize. I have z plus root 3i, z minus root 3i equals 0. So z has to equal plus or minus the square root of 3i. And if you can't remember the rule we're using to factorize, a squared minus b squared is a plus b, a minus b. Now let's look at completing the square. And I notice that my question has equals 0, which means solving, and my question has factorize. Okay, so let's look at both. Let's look at both factorizing and solving over the complex field. So first of all, to use completing the square, we looked at our middle term and we divide by 2, and then we square that and we get a quarter. So that means that if I had z squared plus z plus a quarter, that would equal my z plus a half, all squared. Okay, so we need to make our z squared plus z plus a quarter into z squared plus z plus 3 because that's what I'm starting with. So I've got z squared plus z plus a quarter, and I'm going to take away the quarter and add 3. So that means on the other side with my factorise part, I have to do the same thing. So I minus a quarter plus 3. So that means I've got z plus 1 over 2 all squared plus 11 over 4. Now this is where we couldn't go any further before because we have the plus there. Now, depending on the question, this is where I would take two different stances. If I was solving, I wouldn't factorize here. I would just go z plus a half all squared plus 11 over 4 equals 0. Z plus a half all squared is negative 11 over 4. So z plus a half is plus or minus the square root of 11 over 4, which is, negative 11 over 4, which is plus or minus the square root of 11 over 2i. Okay. Now, if the question did say to factorize, we need to be able to change that plus to a minus so we can do it. So we've got z plus a half all squared. If I want that to be 11 over 4, negative 11 over 4, if I times by I squared, that's the same thing because I squared is a negative. So negative 11 over 4i squared is negative 11 over 4 times by negative 1, which is 11 over 4. So I haven't changed anything, but now I can factorize it because it's difference of perfect squares. So I've got z plus 1 over 2 plus the square root of 11 over 2i and z plus a half minus the square root of 11 over 2i. Okay, I'll do the next one the same way. I'll factorize and I'll solve, but first of all, we have this 2 out the front, so we need to get rid of that. So we're going to go 2 bracket z squared minus a half z plus a half. Okay, and I'll do both solving and factorizing, but first of all, we'll just go for completing the square. And I'm going to complete the square for what's within the brackets. So I've got negative a half, and I divide by 2, so that becomes negative a quarter. And then I have to square that, so negative a quarter all squared is 1 over 16. So that means my z squared minus a half z plus a quarter would be plus 1 over 16 will be z minus a quarter all squared. So remembering that this 1 over 16 goes there and the minus a quarter goes there. Okay, so our z squared minus a half z plus 1 over 16 to make it equal what I've got, which is the plus a half. We need to take away our 1 over 16 and we have to add our half back on. So we do that the same way to the other side. Minus 1 over 16 plus a half. And that's z minus 1 over 4 all squared plus 7 over 16. Okay, so that's my completing the square. I now have to come back to what my problem was. If I was solving, I would have 2 bracket z squared minus a half z plus a half equals 0, and I can get rid of the 2 because I can divide both sides by 2. So putting in what I've got, I had z minus a quarter all squared plus 7 over 16 equals 0. Z minus a quarter all squared would be negative 7 over 16. So z minus a quarter would be plus or minus the square root of negative 7 over 16, which is plus or minus square root of 7 over 4i. If I was factorizing, I have the 2 bracket z minus a quarter all squared plus 7 over 16, which would be 2 bracket z minus a quarter all squared. I'm going to put minus 7 over 16 I squared. So now I can factorize. So I've got 2 bracket z minus a quarter plus the square root of 7 over 4i, z minus a quarter minus the square root of 7 over 2i. You don't really need the square brackets there because you've got the double brackets in the middle. So you could get rid of those. And that's done. So I've done both methods for those 2 questions. Now I do have a solve by completing the square. I kind of really don't need to do this. So how about you pause the video and do it? It kind of tells me that those 2 previous questions were meant to be just factorize. So pause the video, have a go yourself, and then check your solution with mine. Okay, so for this one, I'm going to do it both ways again. I'm going to do it as if I was just solving, but also the factorizing method. So you look at both. First of all, we need to bring that 4 out the front. So I've got x squared plus 2x over 4 plus 1 over 4, which is 4 bracket x squared plus x over 2 plus a quarter. So now I'm going to complete the square for this bit here. So I've got 1 over 2 divided by 2, which is a quarter, and then my quarter all squared is 1 over 16. Okay, so that means my x squared plus x over 2 plus 1 over 16 would be x plus 1 over 4 all squared. But I don't have that, so x squared plus x over 2 plus 1 over 16, to get it to be the 1 over quarter, I would take away my 1 over 16 and add 1 over 4. Do the same with what's in the bracket. So I have minus 1 over 16 and plus a quarter. Okay, if you struggle with completing the square, you're probably better off practicing it on its own without worrying about complex numbers. Anyway, so this becomes x plus 1 over 4 all squared plus 3 over 16. Okay, so that's more as my interlude to complete the square. Okay, so let's continue. Let's solve first. So I would have 4 bracket x squared plus x over 2 plus 1 over 4 equals 0. I can get rid of the 4 because I can divide both sides. Replace my bracket with what I found down here. So I have x plus 1 over 4 all squared plus 3 over 16 equals 0. X plus 1 over 4 all squared equals negative 3 over 16. So x plus 1 over 4 equals plus or minus the square root of negative 3 over 16. So now I have x plus 1 over 4 equals plus or minus the square root of 3 over 4i. I need to take that quarter across. So I have x equals minus a quarter plus or minus the square root of 3 over 4i. Now let's do it using the factorizing method. So that would be the same up to that step there, but now I'd factorize it. So I'd have to have x plus 1 over 4 all squared. I need the minus, so I change it to 3 over 16i squared equals 0. I now factorize, so I have x plus 1 over 4 plus the square root of 3 over 4i, or x plus 1 over 4 minus the square root of 3 over 4i equals 0. And now using my null factor law, I have x equals minus 1 over 4 plus or minus the square root of 3 over 4i. And we're done. Now let's use the quadratic formula. So use the quadratic formula to solve 4x squared plus 2x plus 1 equals 0 over c. So our a equals 4, our b equals 2, and our c equals 1. So x equals minus b plus or minus the square root of b squared minus 4ac all over 2a, which is going to be minus 2 plus or minus the square root of 2 squared minus 4 times 1 all over 2 times 4, which is negative 2 plus or minus the square root. 4 minus 16 is negative 12 over 8, which is negative 2 plus or minus square root of 12 I all over 8. And the square root of 12 can be simplified. So square root of 12 is the square root of 4 times the square root of 3, which is 2 root 3. So this becomes negative 2 plus or minus 2 root 3 I all over 8. And we can bring out the 2 at the top. So we have negative 2 bracket 1 plus or minus square root of 3i all over 8. And then I can cancel before. So it becomes negative 1 plus or minus the square root of 3i all over 4, which can be also written as negative 1 over 4 plus or minus the square root of 3 over 4i. Now let's look at complex solutions as conjugate pairs. As previously stated and observed, if delta is less than 0, then the equation has one pair of complex conjugate roots of the form a plus or minus bi. And you should have seen that with everything that we've solved. So if we come back to here, that's a complex conjugate pair. Go back, each one are conjugate pairs when we've been solving. Okay, so one of the solutions to x squared plus 4x plus 7 equals 0 is x equals negative 2 minus I root 3. Determine the other solution. Other solution is the conjugate, which would be negative 2 plus I root 3. And that's by definition. Next one is known that one solution of the quadratic equation ax squared plus bx plus c equals 0 is x equals 2 plus 5i. Use this information to calculate values of a, b, and c. So if one solution is x equals 2 plus 5i, other solution is the conjugate, which is 2 minus 5i. Okay, so that means that ax squared plus bx plus c has to equal x minus 2 plus 5i and x minus 2 minus 5i. Okay, so we have x squared minus 2x minus 5xi minus 2x plus 4 plus 10i plus 5xi minus 10i minus 25i squared. So that means I have x squared minus 2x minus 2x minus 4x minus 5xy plus 5xi is gone. 10i minus 10i is gone. So that leaves us with plus 4 plus 25, which is x squared minus 4x plus 29. So that means our A equals 1 and B equals -4 and C equals 29. Okay, so the other option of doing this, which saves all that expanding, is from that step to go x minus 2 plus 5i, x minus 2 minus 5i, and then bring it together from there. So you've got x minus 2 all squared minus 5i all squared. Expanding the brackets here, you've got x squared minus 4x plus 4. Expanding your 5i all squared, you've got minus 25i squared. That then becomes x squared minus 4x plus 4 plus 25, because our I squared is a -1, which is x squared minus 4x plus 29. Same answer, and to go from this step to this step, you're using a difference of perfect squares, so a plus b, a minus b equals a squared minus b squared. So all the way, you get the same answer.